Ciao guys, so welcome to my YouTube channel. So in this video we are going to see how to make this model. So actually I got a comment saying that my audio in the last two videos it's not that great. So what I'm going to do is like I did an alternative way in these videos. Like in the upcoming videos though I am trying to correct that mistake, and please let me know in the comment section if the audio is clear or not. Okay. So now let's go into the video. Before we are making the model, I just ask you to do one thing, like subscribe to my channel. Subscription is so good for me. So I have opened Grasshopper. I don't need to tell it. Like you can type Grasshopper in the command prompt of Rhino, you will get Grasshopper. So technically, we just need to create like a base, but not like a cylinder, but like a vase shape, like in the top it's been compressed. So we are going to see like 3 to 4 process, like 4 intermediate process to get the final output. Okay, now we know what is the final output because like I already showed, we just want to create something replicating this shape. Okay, not exactly we are going to try, but mostly the concept will be the same. So first I'm going to use construct point. Yeah, so the construct point is the component which creates a point based on the input value of x, y, z coordinate. By default it has 0 comma 0 comma 0, that is origin. Before we proceed, like use bifocal, because if you have bifocal you get this kind of label, so that if I use this for you it is more easier to understand what component I'm using. And now I'm going to use polygon, like I'm going to create a polygon over here. So I'm going to use this point as a plane, and now I'm going to give a radius and the segment. So what I'm doing is I'm double clicking in the canvas. You get a search bar where if I type a number, by default it gives me a number slider. So that's what I'm trying to do. So I'm creating a polygon with 15 sides and the radius of 20. I'm just like monitoring them. So now what I'm going to do is I want to create a multiple polygon, like a multiple number of polygon, and I need to scale that down. So that's the process we are going to see. What I'm going to do is I'm going to use move, and I'm going to connect it over here. And now, like there is like two ways of generating a list of numbers. One is range and another one is series. Now I'm creating range, and over here I'm taking a panel, like I'm going to create a domain, that is like I'm going to assign a start and end value from 0 to 100. From in this I just need a value like 50 values inside, like for example, if this is 0, this is 100, I need a 50 values of equal interval between the numbers. So I just connect it over here. You can see I got like around 51 numbers. So in range the 0 is being counted, like when you give 50 it counts as 51 numbers. So now I'm going to connect it over here. So when you want to move, now I have the value, but I also need to give a direction. What you can do is, like usually I give like unit set. Okay, but you can also do another way. I'll just show you. We can do it by using plane. So I'm creating a plane, XY plane, with the point as reference, and using this plane for the polygon. Okay, I'm just inserting a plane. Now I'm going to deconstruct this plane. Deconstruct plane. Okay, so when I deconstruct the plane, it gives me a origin of the plane, it gives me the x-axis vector of the plane, it gives me the y-axis, and it gives me the z-axis, which are the three vectors. So if this, right, I'll show you. If this is a plane and it gives me a vector of this, it gives me a vector, and this gives me a vector. Now it looks like normal, But when you use a plane in a like a perpendicular plane for a like a random curve, at that point of time, this one will be useful. Instead of using pull point or pull curve, this one will be more accurate sometimes. So I just use amplitude. So now the amplitude is over here, and we have the vector from z-axis, which is the direction on of which we need to create the numbers. So now we got the like 50 polygons. Okay, a list which has like 50 polylines, like not sorry, polygons. So now we are going to manipulate this polygon with a component using scale. So now I'm going to use scale over here. Okay. So you can see like why it is being scaled, because according to center it takes like 0,0 as center. But if I want to scale it in x and y axis in every circle, then I need to create center for all the 50 points. What you can do is you can create area, and you can create polygon like here, and you can connect it over here. Okay, sorry, I need to connect the polygon here because it has only one polygon over there, the move polygon. So you can do this, or else you can also, what you can do is you can create move again here. Use this, like use the same vector value over in the motion and create a geometry from xyz plane, or like you can use like construct points. So it has the same process. Instead of moving the polygon, we are using moving the construction point. So you can do any either step. So in Grasshopper, the algorithm can be created in different ways, and each algorithm will be unique way of approach from others. So you don't need to follow a set of rules. What I'm doing, I'm trying to do this because you just need to understand the principle behind each and every component I'm using. So that's why I'm just using as an example. You can create your own when you start using creating the algorithm by yourself. Sometimes you will create something unique when you are not like by yourself. Like when you're creating more like 3 to 4 algorithms, like when you're practicing it again and again. So sometimes you'll come up with different unique algorithms. So now what I'm going to do is I need to manipulate this scale factor value. What I'm going to do is I'm going to create a range again, but in this case I'm going to use this step value here. But for the domain, I'm going to set the domain as like 0 to 1, which is already being set by default. Now I'm going to use a graph mapper to manipulate the data which I'm generating. So what I'm going to do is I'm going to use Bezier curve. Like Bezier is my most favorite. So like let's check like this. Okay, for now. Then let's remap the number. It's kind of like we are like changing a number based on the domain, like the domain which we are creating. Source is nothing but the maximum and minimum value of the list, which is technically the 0,1 because you already set the domain. You can use bound over here, or else when you're setting a domain, you can connect the domain over to the source. So the bound gives me the maximum and the minimum. Now I'm going to construct a domain. So the number which is being in the graph mapper should be changed proportionally to the number which I'm creating in the domain. So what I'm going to do is I'm going to create like a 0.55. So now I'm just going to use this mapped over here. You can see it's been changed. The shape of the structure has been changed. So now what I'm going to do is I just like going to change the curve value like over here. Okay, not bad. So now what I'm going to do is I'm going to rotate this. You might be asking, bro, why are you rotating it? Like, I'm just rotating this, so there is like 50 curves, okay? Like 50 polygons. If I explode this, right, I'll just show you why I'm rotating. So I explode this and create a value like maybe like a polyline. Okay, polyline interpolate. Like I use the segments, it creates a line like this. Let's flip the matrices. So it flips the trees. So you can see now this polyline which we created without rotating, it's straight. So when I rotate the polygon, I'll just show you the difference. So what I'm going to do is, you can see this is like in angle. I need to change it to degree, or else you can create a radian component. So this one create like from degree, like the value which you give in degree, it's all it's been converted into radians. And so it's like it's up to you. You can either change it degree directly over here, or like if you want to input in radians but your value is in degree, you can convert it like this. So I just use range again here, but in the domain I'm just going to give like 0 to 180 degree of rotation, and the numbers are the same like the steps over here, because like this is the number, because we need to generate the value. Like we have 50 polygons, so all the values which you are generating should be matching the same number, which is like parametric. At last when you change that number slider, you at the entire model will be changed. So now it's been rotated. Okay, now you can see no difference, but I use the same control C control V over here, and when I connect the curve over here, so you can see the difference. What I'm doing is like here when I rotate it, so as a model you don't wait, I'll show you like in the endpoints. So here all the start and end points are the same, all the polygons, but when I rotate it, like it creates like 50 values like from 0 to 180. So the first polygon will be in 0, second polygon will be like a 3.6 degree rotated, third will be like 7.2 degree rotated. So in this case, when I connect the rotator geometry, you can see the start and the end is been changing, as well as when I explode this, then all the vertices is being moved. So when I flip the matrices, like if I don't flip, it creates like this, but when I flip it, it creates vertical. So all when the points are being rotated, you can see like this point is being moved. So what is the difference between flip matrices is like, right, I'll just generate like 0, 1, 2, 3, okay, multi-line data, end twin. I'll just show you the difference between flip matrices. Okay, so when I create this number, you can see like all the value is being generated like in a different branch. So the 0,01 branch has like the value, like I just use the same value in 3 different branches, so it's been given as 3 different branch. But when I use flip matrices, so this 0,0,0,0 will be in one branch, 1,1,1 will be in one branch. I'll just show you it. So you can see the 0,0. So all the so it has been flipped. The indices become the branch becomes indices. So the indices of 0,0,0 becomes one branch. So the indices of 1,1,1. So these are the indices number from the line. You see these are the indices number. So that becomes like a branch. So the same concept over here. So it becomes like the point is being acted as vertical. So this is how I'm just explaining for now what the flip matrices is doing here. So now as you see, like we got the 1 minute, I'll just delete this. And this one is like just an like an, like, how do I say, just an, like, to show what is the difference. Okay, now, like, let's keep this aside. Okay, now we are going to play with this curves, like they explode. So I just hide everything else. Okay, so the points are, you can see the points is being moved. So what I'm going to do is I'm going to create a line SDL. So line SDL is like it creates a line from start, then we need to give a direction, then we create a line. So not from start and end. So now we have the vertices, which is a start point. Now you can see the line has been created in the top way by default. So what I want to do is, like, I want to make this line go outward of the point, like outward. So what I'm going to do is, like, it's so simple. I'm going to create perpendicular frame on the segment. So I'm going to use this. Now I'm going to give a value of 0.0. So, and I'm going to reparameterize. So reparameterize, if you see in my last video, like the Naruto video, or like the Chinese roof structure, I explain what is the use of reparameterize, like reparameterize and perpendicular frame. So you can check in that video, like if you are following this, try to follow all the videos one by one, because like in a lot of videos I explain certain components like detailed by using that model. Okay, deconstruct plane. Okay, so I'm going to deconstruct the plane over here, and now for the direction I'm going to use the y-axis over here, and for length I'll just give 20 to show you that, like, the point. Like, let's hide this. So you can see, like, from here it's moving like this. So I'm just using the perpendicular frame, from that the y-axis. So here the perpendicular frame, the y-axis of the perpendicular frame has been changing. So that, as I said in the start of the video, the deconstruction plane is so helpful, because when I want to create a line which has like different directions, so I just create a perpendicular frame, then I grab the y-axis, like deconstruct the plane, I use the axis from that, which is more efficient way. Like, we also have a lot of alternative ways to do that, but in this way in this video I'm trying to do in this way. Okay, but now what I'm going to do is I'm going to, like you can see the lines are like all the lines have the same value of 20, which I don't need. I just want it to be like or manipulated. So what I'm going to do is I'm going to create like a range again. So before going into range, the number, yeah, okay, maybe I'll just group this group. So this is a number which we are using, number 50. For the domain, I'm not using the panel, I'm just constructing the domain so that I can alter it. If you're altering the domain, then use the construct domain and use it. But I use here the panel because I know that these values won't be altered. Like 0 to 180, 0 to 1, these values I know that they won't be altered to be a parametric. So that's why I didn't change. I didn't use construct domain, where I don't need to change any value. So here what I'm going to do is like maybe I'll just use, like, for now 0 to 1. You'll be like asking, bro, it's the same value, but I will be changing. So right now I'll just use 0 to 1, and for step I connected, then I use like graph mapper, and I just connect it over here. As I said before, my favorite curve is graph type is desired. Now I'm going to use remap numbers. So as I said before, the numbers is been remapped. So now I get bound. You can use bounds or you can connect it from here. Okay, it's up to you. Now I'm going to use construct domain. Maybe I'll just copy this, Control C, Control V, and yeah, let's keep like I want to change all the values to a range of 0 to maybe 10. Okay. Now I just need to graph this, and I'm going to connect it to the length. So if you don't see the difference, okay, let's connect it like maybe like let's loft it. Maybe I can show you the difference. Okay, let's flip the matrix. Okay. You can see like I have like two curves because here in the same place we have start point as well as end point. So the line SDL creates two set of lines over there. What I'm going to do is I'm going to sort the list over here. Not sort, sorry, split list. So in this, I'm going to use the vertices over here, and then I'll give like value of 15. The value, this one has been generated from the start of the segment, the number of segments we give. So here we just join this. Maybe just simplify and simplify this. Okay. So you can see, so at the end, you can see the value like, what do I say? It starts with a 0 and ends with a 15, something like that. But I don't need this. Let's see. Okay, so instead of changing that, I'll just change the curve over here. I'll just bring down the curve here because I just want the center. So by this graph, it says like so 0 to 1 is like so this one is 0 and this point is like 0. So we are just manipulating the curve. So by this you can see like these two becomes like 0, the value of the top and bottom, because like this is the top, this is the bottom, and the curve is like the curve creating between the in between the curves. So I'm just like making like here, like I'm just adjusting a little bit. Okay, not bad. So this is the one I need. So I just like lofted this to show you what we are really doing. So now I'll just show you the image. So now we got this one surface. Now we need to create another surface, and then we need to join these two surfaces. Then we need to connect these surface, and maybe I'll just. Is there any way I can draw on the image? I don't know. So I'll just show you when I'm doing. It's not that complicated process. Like I'll just show you. 1 minute. Sorry, I'll just move this here. I'll just keep the loft over here, the flip matrices and loft, which is not needed right now. So let's simplify this. Okay. So what I'm going to do is I said before I just need to create another surface. So I use the same SDL over here, and I'll just keep it here. And I just move this here. So in the second SDL, I'm going to use the same, but in this like the only thing which will be changing here, like I'll just use Control C, Control V. But I'll change the domain. The domain will be changed, and I'll just connect this over the length and the direction of the point. So instead of like the sort list which we're using here, we will be using the same how do I say, we'll be using the same over here, this part. And wait a sec, I'll just move it here. I'll just show you. So in this case, like you can see, this is the origin point. So I'm just going to like move this maybe a little. So you can see the so the perpendicular frame is like if this is the frame and point, this is like 0.0, this is like 1. So if I move like point one side, so this one is moved like on the both, like top and bottom, it's moved like this. So it's like it's moved to 0.15. So after this, I can rotate the axis. So so I'm just using the y-axis over here, and like I'm just rotating it. So let's use degree here. Like in the last I used radian, so it's up to you. Like I'm just using, like I'm trying to use all the options so that you can see like what are the options are really available in this. So I'm going to use like a control C, control V for this. So I'm going to use a remap number, and for the value I'm going to use the same value from the graph. And for the source, I can use a domain, construct domain over here, or else I can use bound. Okay, so now we got this value over here, and I'm going to give this value to the angle, and now I'm going to use this geometry over the direction. So if you don't know what I'm doing, like I'll just show you. So you can see the points have been like, I'll just give 20. So you can see it's been moving on the right side. So the start point, if you want to move the start point, what I can do is like I'm just moving like over here. So what, it's not moving because like the start point is here, I'm just using the origin. So now I'm just moving the start point to the origin which I rotated. So now you can see like the first the surface, like wait, I'll just loft this, control C, control E, sorry. I just hide everything else, even this. So now I'll just show you, you can see. So the loft lines are be moving in and out. So I'm just like, I can use like for now 10 over here. And you can see the point is being like, you can see it's like it's moving from 0 to 1. So for now I'll just keep it for like 15. Maybe it will be little confusing, but once you start to work on that, like don't try to copy exactly what I do. Try to understand the changes when you connect, like take it slowly. Like when you try to add one component, try to see what changes you can see like in the model when you're changing the component. Okay, because Grasshopper is a kind of self-learning software, like you just need to do practice, like understand the concept, practice it. So now we got like two like a two surface. So in this point I just use like end points. I get the points over of this surface, like where I flip the matrix, flip matrix I'm just saying matrix, sorry. Like a polyline. Okay, I used a polyline over here. So you can see like I got the edge of you can also do like explode or something, like deconstruct bit up, but I'm just using endpoints over here. The same way I'm going to use like Control C, Control V, connect this over here, and what I'm going to do is I'm going to use a ruled surface. You can use loft, but I'm using ruled surface here. So merge. This is the first surface. This is the second surface, and you see the third one is hidden, which we really don't need. What we just hide this for now. You see there's like 1, 2, and third one is like I need to connect this curve. To just show you, not this curve, the end curve. I need to connect this curve towards this curve, like if I'm not wrong. Where is the poly curve? Okay. Okay, so wait. Okay, so what I'm going to do is like I'm going to create polyline. I'll just create this over here. Flip matrix. Okay. So I need to connect this curve towards this curve. So what I'm going to do is like I'm going to use like let's keep it maybe for now let's delete this. I'll just use merge, and I'll use this as a curve, and let's take it over here. I'm just flattening this, flatten, then connect it over here. So when I flatten, you can see like there's like 14 curves, and if you see there is around 14 curves. So what I need to do is I need to match these curve 0, 0 curve in a single branch. I need to branch it like that way. So what I'm doing is I'm going to graft it over here again. Let's see. So you can see like two polylines like polycurves are being created, but when I loft this, like I don't get what I want. You can see these two is being connected, but I want this curve and this curve to be connected. So what I can do is I can use a shift list, and I just connect this, and I use 1 over here, so shift over here, and like I hope it works. No, it doesn't work. Let's connect like this. Okay. Wait a sec. Okay. Okay. And why it is not lofting? Okay. Simplify. Flatten. Okay. Simplify. Okay. The branch has been changed. Flatten. Now it's been grafted. Sorry. Flatten. Okay. Yeah. So I just need to check the branch over here. Like wait, like if you see like when I do Control Z, you can see like the branch is like 0. Here is like 0, 0, 0, and the curve we use like here you can see it's only 0. So that's why I just flatten this. So it comes in both branches like 0, 0. Now when I graph like this 0 becomes as a single branch. I'll show you. You need to manipulate the data. You just need to understand the data. So 0 1 0 1 0 1. So now we got this. So now the model is like kind of done. Like it's done. Okay. As I said, it's so easy. Okay. So there is an alternative way to create this surface. The last surface which we created. Wait. I'll just like turn this off. Okay. What I can do is like I create like a line. Now what I'm going to do is like I'm going to use the line STL like I said. So I'm going to use the end point in this, and for the for the end point towards the start point. And now I can use like the construct plane. That's it. Okay, sorry, the deconstruct plane. I can use this point like shift list, because like it should be moved one way, so one direction, so that I can create the diagonal connections. Maybe I'll just give point. So I'll just hide everything. So you can see there is like a diagonal curves which has been created between two point series. Now I'm just going to give loft, but flip matrix. Okay, so you can see now it's been created. So it's like it's so when I hide this, so you can see like I'll just show you both the loft. So you can see now the loft has been created. Sometimes there will be like small difference in the detail, but it's up to you. You can choose your process, which process you want to do. It depends on what is your output and stuff. So now let's turn on this, and let's turn on this. And you see the loft is created. Now let's pipe this. Everyone. Seriously, one is too much. Well, because in this image I see this line. So instead of line, let's pipe this. Okay. So this is the model which has been created in the image. If you want, you can manipulate a little. However you want. You can, if you want, you can increase the number of curves. If you want also, you can increase the height. Like 150. So you can increase the height. You can change the radius. So this is technically the parametrical. So like you can change with different types, different values. I'm just changing the number slider, okay? So the model has been changing. So this is how it works. So if you have any other doubts, please let me know in the comment section, and subscribe to my channel will be a plus. And if you think this video will be helpful for your friends or colleagues, you can share it to them. So thank you for watching the video. Please let me know any queries or something in the comment section. Bye bye. Share as much as possible. Have a good day.